Welcome to this talk, immersive storytelling with graphics, code, wit, and all that. Can I, just before I start, get sort of a show of hands? How many of you, if any at all, work with storytelling in any way, shape, or form? Wow.
Nice.
That's really cool. I was expecting like 0. So that's super. That's great.
Great.
Fantastic. Yeah, we are from VG, which is Norway's most read newspaper. We have millions of visitors and readers each day, every week. And we're here to talk about storytelling. That is, telling stories through and in the web browser across devices. Really, the talk is more about our work specifically that we've done on storytelling within VG. And we hope that this talk will be sort of relevant also to the people here who haven't worked with storytelling, like in UI or any user interaction at all, really. And I hope it's sort of inspiring. It's a bold statement, be inspiring. But I hope it's inspiring to those who like to tinker with graphics, code, and make things in general. And perhaps we can enlist future colleagues, because we need more people. And this is a part of like computer software that isn't much talked about to work in the news. And lastly, we want to be transparent about what the media is actually up to, because there are lots of misconceptions about the media.
Yeah. So whenever we put we have these journalistic projects that require some sort of output that we can't just solve in the CMS. We make the web application outside of the CMS, and we refer to these as specials. And through the wonders of the Internet Wayback Machine, we found this one, that this is a special that VG had in 2008 covering the Norwegian sex market. I mean, you can just look at the information architecture on this page, what sort of screen sizes we were targeting back in the day. And just to put a recent example, this is another special. I would say it roughly has the same amount of content as the one from the 2008. We published this on Sunday. It's a totally different approach to at least information architecture and accessibility. Yeah. I think you turned off the screen.
I turned off the screen. Yeah. Great. Off to a great start. Yeah, so the way that we consume news has certainly changed over the years, from the 1900s earlier too, with text-heavy news articles in newspapers. You're in a quiet location and you're reading through it all, consuming it all at your own pace. We are now consuming more and more through screens, have different expectations of graphical content, and we're also in a lot of different, often stressful environments when we read things. So we have different expectations of how it's all wrapped and how content is presented.
Yeah. So like Einar said, how we expect to consume journalism, it has definitely changed. We went from having the absolute attention to all the readers, now, let's be honest, absolutely no attention span at all. So we've gone from reading the news to being spoon-fed or spoon-feeding ourselves with news.
And that's what we're trying to navigate, between on one hand having quality content but presenting it in a way that's boring to people or perceived as boring, and on the other hand dumbing it down, really stripping details to a point where it ceases to be the story that it actually is, in order to be appealing, visually appealing, information-wise appealing to people. So we try to navigate that, and our goal essentially is to strike home with all of these kinds of readers, across the different devices, across the different situations that you are in when you consume the news. But we are a couple of old guys in our 40s trying to be innovative and reach a younger audience. That's difficult. But I'm Einar. I'm actually the head of security at VG, which is weird as well, since I work with these things much of the time. I've been in software biz since 2001, but left that in 2014 when I came to VG. And within VG, I worked on a great deal of different things.
Yeah, and I'm Jonas. Like you, started in the software business in 2001. A bit earlier entry to the media business in 2007. Did mainly work on the CMS side of things before venturing into the editorial newsroom in 2014. And joining VG 2 years ago. By the way, when my first job title in 2001 was web designer. Anyone else had that title ever on their resume? Great, super. Yeah, quick background. Like I said, I started mainly working on the CMSs, on designing the front end of the web page. But since 2014, I've been working mainly on big news stories. Since I joined the newsroom, covering child abuse, drug sales on the dark web, data theft, also like positive stuff like sound-driven photo stories from Antarctica, but yeah, mainly done like visuals and front end for investigative journalism.
My entry into VG was a little bit weird. So I came in there mostly as a researcher early on, and I worked a lot of dark and sort of depressing but still important stories in my time in VG. But come 2018, I started in 2014, so after 4 years I was pretty much spent and had to do something completely different. And this turned into me starting to tinker with the Unity game engine and getting further into Blender 3D. And that first project was weirdly a cross-country skiing game where you're a hot dog trying to escape elks and so forth. This was really weird, but for me personally, highly necessary to just get out of the stuff that I had been working with. And it turned out to be really relevant as well for other projects that followed suit, like this frigate that crashed into an oil tanker outside the western coast of Norway in late 2018, where I could sit down with Blender and Unity once more and combine GPS data, LiDAR data, and sound recordings from what occurred and try to tell, like bring the reader into that fateful night and show underwater conditions, overwater conditions, and try to simulate the crash between the oil tanker and the frigate. So that was really, really interesting as well.
All right, now to the fun part, stories we worked on together. So the presentation starts now. And now we're going to turn it up. We're going to start on this one, just known as Skredet, which was a quick landslide in Gjerdrum, north of Oslo. Happened during Christmas of 2020. You can see here some photos taken in the aftermath. Many buildings were destroyed. 10 people lost their lives. And we were tasked with presenting the facts and the rescue efforts. It was an absolutely massive slide. This is, I think, a drone photo taken some days after. I mean, pay special notice to these small houses that are on the top. They aren't small. They're really, really big houses. I think they're like four family homes. But you kind of lose the sense of scale when you see it from that far away. Nice place to stop. And this is the area, how it looked before. So our goal was to make a before and after type visualization. And remember, this was an ongoing event still. There were still like movements in the ground, in the pit. And this happened during the Christmas break. So we weren't at work, so we were already late come 4th of January when we started up the new year. So we needed this done fast. And this was a kind of infographics that were created in various media. Just took some screenshots. They don't really convey the scale at all. Also, this slide, it happened during the night, so we had no photographers on call that were there. Bad lighting, poor imagery, and when daylight came, the whole pit had closed because it was actually hazardous to be in or around the pit. So the only photos that we could take with our photographers were like with a telephoto lens taken from a distance. But this just doesn't tell the story good enough. So we need to take the readers and bring them inside the pit. So we thought that we should maybe make this like a 3D visualization. And that's okay. I mean, we are, as consumers, we are spoiled by 3D graphics in film and in games. I mean, 3D worlds, they can really be immersive. They can transport you to another place and time. I mean, this is like background scenery from a now 6-year-old game called Red Dead Redemption 2. And we're also late. It's been a few days since this happened, and we want to do it in 3D. And the target audience is not on a PlayStation, they're on a mobile phone. So how do we get like Hollywood production quality on something? It's like setting ourselves up for disaster, really. So I started VG the day before, and had a quick chat with Einar. He was doing all the model stuff. He had some LiDAR data. He's going to talk more about that later. So I asked him to send me some sort of quick like model of the terrain. Didn't happen because you were in your cave making all the stuff work. So this is like the answer to how do you get Hollywood production quality in the browser. This is like the quick like storyboard sketching. It's of course not to Hollywood. So it's a really, really simple design language where we like have this monochrome landscape. We're just highlighting the polygon edges. I mean, also 10 people died. So we can't like, be like fancy with graphics. We have to be clean and factual. And yeah, basically just concepted this whole, just using a mock 3D landscape I found online, trying to make some sort of timeline, and the concept was that we could be really, really clean and also show the actual photos that were taken on this canvas. Yeah, the ugliest slide I ever made, but this was basically the whole like design language for this. Really, really 3D landscape with highlighted polygon edges. But the buildings need to stand out and they can be white, and we can highlight them just using red, which is VG brand color. And then when the building is destroyed or taken by the landslide, we can just play with the opacity. In addition, we had lots of videos and photos. Yeah. So let me just show you quick how this looked. Again, everything here is made for mobile. That's the target screen size for everything we do. But somehow, when we're doing these presentations, the desktop version kind of lends itself better. So that's what I'm showing. This is the splash screen. It roughly translates to the slide, and then comes the subtitle, when all hell broke loose. And visually, we have like a small slice of Norway. Let's see. It plays. So it's night and calm in this residential area. And Stein and Mona, they're sleeping in the house. They start to feel tremors. Earthquake, Mona thinks, as the house wall just rips apart, tears open. So she clings onto her mattress as it's being catapulted outside through where the wall used to be. And then you see the after state. And that's, of course, the beauty of running an actual 3D model in the browser. Because, like here, we can connect the real people we meet to the houses. We can bring the readers as low into the pit as we want to. We can show them a bird's eye view, showing the extent of the slide. They were taking some iconic photos during the coverage of this that we can show where it was in relation to other items. And in addition to this, the 3D model we had, okay, this is like hardcore PowerPoint, so I'm going to show you 3 things at once, but we had these slow motion portraits of people we met. This is the mayor of Gjerdrum. And in the middle we got footage from the rescue helicopters, so we could also pinpoint them in the 3D model. And we also had like traditional drone footage from the aftermath. So, Einar, how did we
Yeah, so we were going to make a 3D thing, and so you go to the competition basically and see what's readily available of 3D models from an area in Norway. This is Google Earth, and according to them, that part of Norway is really flat, much flatter than Norwegian sources say, because we in Norway have great data. The Norwegian Mapping Authority regularly charters planes to fly over and do LiDAR mappings, high resolution of basically all of Norway. So it was a really simple choice, really, to go with Norwegian data over the readily available ones outside of Norway. So rolling our own, this was the overall architecture of it all. Get data, get the maps, get the models from somewhere, feed them into Blender and what have you to mold them, augment them, add other stuff like buildings and cars and so forth, and present the story on top on the web. And this, of course, amounts to like fetching a before model. We wanted to show how this was looking before the slide and after the slide. So before model, Norwegians, the Norway Mapping Authority, Kartverket, and after model we got from rescue services who flew drones over and did photogrammetry and made 3D models of the slide pit. These, of course, were really big models, much too big to run on Granny's old phone. So we bring them into other tools. And before I go into that, I just want to quickly note on these models, because there are many different models that you can deal with when you have height maps and so forth, depth maps as well. We were interested in the surface map, the surface model, and the terrain model. And the surface model essentially is the height of everything, like all the buildings and trees and every dent in the terrain. Whereas the terrain model is the interpolated estimation of the ground level at any point, so below the tree canopies and under the buildings. These were the two different models that we were dealing with. We brought them into QGIS. Could have been any other similar sort of mapping software. QGIS works fine. It's free, open source, works really well to simplify the models, cut out pieces of the terrain that we wanted, and also to align the before model with the after model and make those into distinct, properly aligned models. Those were then brought into Blender, which is the most wonderful software ever, in my opinion. I really love Blender. That it's free is insane. And after that, take it even further and place objects, buildings, get buildings from Nordkart, which is a commercial actor here in Norway. We could have also used buildings from OpenStreetMap, OSM buildings, but Nordkart's buildings are much better. And we added the car that you saw and planks and rubble and all that. At that point, you have something that looks pretty good in Blender. You can play around with it and you can texturize it and do other stuff that I'll come back to. And you can even bring it into Babylon.js, export it from Blender and see it in the web browser. So we could have gone with Tree.js, any other sort of engine, but we have chosen Babylon because of the tool sets that it comes with. Suits our needs really fine. So what's left is to present the story, and that's basically just some augmented Babylon.js stuff with some things on top. And those things on top are, like we have the story in the markup, and we have different variations of this across our stories. But essentially, we either have the manuscript in the markup. Like this is sort of dirty, but we make one-offs, right? So we just make it work and we publish it. Often, the manuscript will be in the markup. Other times, we'll load them off a Google Docs document or a Drive or similar. But once it's in the markup, we tie it all together with an interaction observer or similar to know where the user is scrolling at any given moment and trigger different things. Triggering different things will call into what we've called the storyboard component, which is basically what happens in the 3D model when you're at a certain breakpoint in the text. Buildings are shown, addresses are highlighted, and so forth. which in turn calls into the waypoint system, it takes care of the camera movements, interpolated positions, and what have you. And that's really that. That's all there's to it. But obviously, when you've gotten to that point, you have a story running. You still need to make this work on slow devices as well, because we have millions of readers, and they have a great number of different devices. So we have to test these things on those great number of different devices and make sure it works okay-ish on all of them. There are a couple of tricks to do that, and throughout this talk I'll come back to several of them. One thing I'll mention again is to use unlit materials and to have as few, if any, real-time lights at all. So bake light maps, that is, place the lights that you want in Blender or similar software and render like the lighting effects into the textures, and then load those textures in whatever 3D engine that you use. That's much more performant and runs much better on different devices than you doing it real time on the device as well. Also, decimate like crazy. Decimation is the process of reducing polygon count, so going from a huge number of polygons, which is what you'll get when you make these models initially, to a much smaller polygon count. We used, in this case, a piece of software called Instant Meshes. There are many softwares, many tools out there. Blender has integrated tools for it, but Instant Meshes is interesting because it allows you to draw up like polygon lines in whatever model you're working with. So in this case, I could draw lines for the creeks, for roads, for edges of the slide pit, for other things that were important to keep in the final decimated model. So it'll ensure that you keep a certain level of detail for the ridges as such. Really great piece of software.
Yeah. So that was that story. And this was, like I mentioned earlier, it was an ongoing news event. And we did it in 5 days and 5 nights. But we have one more story, which is totally different because it's planned coverage. So now we're going to see what we can do in 2 months instead of 5 days.
So this is a story called The Fateful Hours in Baneheia, translated to English. The Baneheia case, Norwegians among you will recognize this very well, of course. It was a murder case from 2000 in which 2 young girls were abducted, raped, and later found murdered, aged 8 and 10. It plays out in Baneheia outside Kristiansand. 2 men were arrested in this case. One was actually acquitted last December, and it's important to note that our story was run prior to that. So we built our story around the narrative that was presented in the court case. We've since updated it, but still some of the things that we say and present here don't properly reflect that acquittal. But the events from 2000, as I said, take place in Baneheia, which is a recreational area outside Kristiansand, and it spans multiple hours and a pretty vast area. Things happen here, things happen there, and the sequence of events and where these events took place is important to convey to really understand the story. So our main objective was not to go down the same path as other previous presentations had been. I mean, this was from 2000, so obviously this story had been told multiple times. But most of these times, the story had been just a series of disconnected pictures from here, from there, and with text in between, obviously, and some flat maps, but basically no proper way for people who hadn't been to Baneheia to really understand what happened where and understand the story. So we wanted to bring our readers there, even those who've never been to Baneheia and maybe never will go to Baneheia. So yeah, back to 3D.
Yeah, back to 3D. Similar approach as Gjerdrum. Then again, this is a story that really lends itself well to this kind of topographic presentation. This is I was about to say screenshot. This is a page from a book. Written about the story. And this is a photo from Agder Politidistrict from 2000, where they're trying to map events. So, started the same way as Gjerdrum. This is from høydedata.no, the Norwegian mapping authority. And then you added buildings from Nordkart. And then it looks like this in Blender. Yeah, something's missing. Any guesses? While we were researching this story, we saw this photo. It's taken like a week after the murders in 2000. It's taken with an old camera, SLR, in a flyover. And there's something about, of course, you have trees here. And trees, of course, they obstruct the sight lines. And it's something about how this semi-dark, overgrown area surrounded by these residential areas was really appealing. So again, we need to look at the competition, or can we source our data elsewhere? And in stark contrast to the really, really flat example you showed from Gjerdrum earlier, this is like near a major city. So Google Maps in 3D view looks really, really great. It's lush vegetation, and it's just super. But we needed to go close, and this isn't even close, but when you zoom down, it gets really wonky, and you can see that all these trees, they are mainly just like blobs with green on them. So we were still here. So can you tell us how you planted 30,000 trees?
Yeah, because as I said earlier, we deal with all kinds of devices, so you have to be efficient, obviously, when you render this thing out. So you can't really place 30,000 or whatever sort of detailed tree models in a landscape and expect that to work on Granny's phone. You have to pull some tricks. And like anyone who's toyed with graphics ever or played graphical games back in the 90s know of the concept of billboards. So the first attempt was just to have billboard trees, like these sprites that always face you, and that looks well enough from the sides, but on top it starts looking really weird. It breaks the immersion really quickly. So I tested what I've come to call the plus tree, like also basic technique, like just combine two sprites, put them together, and see how that works. Once again, and this is in Babylon.js Playground, which is a really great tool for testing these ideas out. You have many examples of like loading models and applying lighting effects and so forth, so that you can build off on and add your own code to and save and go back and forth and so forth. But I loaded the plus tree, and once again, it looks great from the sides. The textures here aren't great, but still, the major problem is that the plus tree looks like a plus from up above. So I tried the layered cake tree, which adds like layers all the way up, and this actually starts to look really decent from up top. And I don't know if this like properly captures it here, but you see the layers too much, so this wouldn't suffice either. Wasn't good enough. And at this point, like you're starting to add enough detail and do enough things that you have to not just optimize the model, but also optimize how you deal with the model. So rather than to iterate over a bunch of trees with JavaScript and apply effects there, you have to turn to shaders. And a quick note on shaders for all I know, all of you are well versed in them, but basically a shader is a piece of code that runs on the GPU, right? So even pretty old mobiles have graphical cards, GPUs with a great processing power compared to JavaScript and similar. These shaders are comprised of a vertex shader and a fragment shader. The vertex shader runs, that piece of code runs for each point in the triangles, the polygons that you have in your scene, and set positions, various other custom attributes. And you have a fragment shader that runs for all the rendered pixel between those vertices. So, and that results in color. So shaders are fast, much faster than running things in JavaScript, as I said. And this is an example of such a shader. This is really a hack. Much of what we do are hacks because we have to make things work quickly. And perform well, but if it breaks in 2 weeks, it really isn't that much of an issue. So like I usually say that coming to VG from the software biz, like software biz has always been all about process and like making these processes more and more efficient, whereas working in the press has been to always shoot from the hip. Like you just do stuff and publish it, and you go with the next story, which is really refreshing.
It's wonderful.
Yeah, and so, but this shader will basically just calculate, probably inefficiently, but well enough, the angle between the viewer, that is the camera, and the tree, and place that into an attribute that's available in the fragment shader, the pixel shader. In which case I just read that angle, and beyond a certain threshold, mixed with some noise to get a smoother blossoming sort of transition on these layers in the tree, either keep the pixels or discard them, which will turn them transparent. And at this point, you actually get something that looks pretty well. It interpolates really well between the plus state seen from the side and the layered cake side when you are up above. And it performs really well as well. So you can, and this is like the back end sort of view of the actual special that we made. And I've exposed a bunch of other functions as well, so you can add wind, for instance, noise over the whole landscape and affect colors and really adjust anything that you want. But it makes it possible to render a huge amount of trees in this landscape efficiently, even in the correct positions, if you so please, and have that run nicely on all mobile phones and so forth. And it may seem over the top, but it's really important, as Jonas said, just to properly show line of sight and what was visible from where in this landscape. Could you see the crime scene from the path below? Could you see the baiting area from where the suspects were said to be hiding before abducting them? So yeah, that's one trick, obviously, to making it performant. There are other things as well. And one thing that I did differently in this case compared with Gjerdrum was to try to benchmark as quickly as possible on first load how performant was the WebGL device that was opening the article. So I load up this really heavy, shitty shader and then just calculate the value of how long it takes to process something. And that says something about the device. And this affects like which objects are loaded, how detailed those objects are, and so forth. I also benchmarked the bandwidth of the device, so I can swap textures, for instance, use low resolution textures for worse connections, so we don't eat the data plan or similar. Also try to detect whether it's actually on 4G, 5G, and so forth, but that's really sketchy in terms of JavaScript. Furthermore, obviously, few or no real-time lights. Those are really costly. And custom shaders for all the special stuff, like markers in the terrain. Those are shaders. The water is a shader. And I'll show you an evidence visualization later. That's also a shader. So everything, as much as possible, just throw it into shaders because they're so much more efficient than using JavaScript. And there are a bunch of best practices for Babylon.js and Tree and obviously other frameworks. In Babylon, there are great pages available for that. One of which is, in this case, to block the material dirty mechanism, whatever that is, and to freeze the world matrix. But should you wish to work with this, just look up the best practices for performance in these toolkits, and you'll find loads of resources. And of course, to reduce the amount of models. So in this case, what makes this work at all, in addition to the shaders, was to have the trees be Babylon.js thin instances rather than 30,000 individual trees. Those are just like one tree, or actually 3 different trees, but cloned 30,000 times, and you end up with just a minimal set of attributes that are unique to all of them. And that computes much, much faster than to have loads of individual objects, obviously. And as I said, the water is also a shader. So this is just an example of that. You probably can't read it. It's not important. But I feel that it is, in this presentation, important to have more than just a flat blue sort of water. So being able to add a hackish sort of reflection of a skybox that isn't there with some rippling effects and so forth makes it look a lot better. And again, this runs smoothly on age-old iPhones and Androids, so why not?
Wow, thank you, Einar, for setting the stage. Like, really. So now we truly have a canvas that we can tell the story on. If you see all the gray, the foggy stuff in the background, that's actual terrain. But so the visual point here is similar to Gjerdrum, where we had like this tiny block of land. Now it's all just circular stage. And you see that all the houses, they are there basically as set dressing, because they are not like main actors in this story, but they are there to represent the different bydeler.
Parts of town.
Yeah, parts of town works. But we need to place the actors or the persons on this canvas, and trying to animate suspects running through the forest, or small girls swimming. It will be technically challenging, and it would also be extremely tasteless. So, as often is the case, simple is the best. So the thought here was, okay, we can just place them as these circular markers, also drawn through the shaders, with a really contrasty white border, so they're easily separated from the background. And we need to tell them apart. So we gave them colors. And I've been working as a designer for 22 years now. And I know that colors can cause emotion, but this time it was really intense, because we are working on an awful story, and people really have different perceptions of colors. No, that guy can't be that color because I get those sorts of associations, and no, he can't be that color. So anyway, it was just on with the maths. So basically, the coloring scheme is done with a simple tritone coloring scheme that were slightly adjusted just to reduce the pink. It was also very important. And the red value and the blue value are used for the two suspects in this story. And it's important that we have this sort of spread between the colors, because if you are having some vision impairing, if you are colorblind, you should always be able to distinguish the two when they are in the same scene. And what we did for the father and for witnesses, which are just like deviations of the third point, you don't have to be able to distinguish them, because they are never in the same scene at the same time. And also, just using some like mapping typography, as you're used to seeing in an atlas or Google Maps or any other sort of map, just to convey that our 3D world here, it is like a map. It's like map 2.0. And then the stage is set. And now we can begin authoring the movement of all these people, and we can start to set the camera angles and so forth. And everything so far has just been like generated from height data and building data, in addition to, of course, the 30,000 trees that you grew. But there are some locations in this story that needed to be created that we just couldn't like generate from data. Like landmarks, like the playground is really important to the narrative in this story, because the two men that later were convicted and later one acquitted, they were observed on this playground, so really low resolution models imported. And also the road barrier. Was one of the guys, was he inside or was he outside of this road barrier? And also the bathing area, that the girls were last seen alive. So, finally, we can look at least the intro of this story, see how it looked online. So it starts really, really basic. It's almost a cliche now, where you it's gone inflation into it. Where you have these sticky images that respond to the text. But even if this is a really well-known story in Norway, we just have to like explain it in a few sentences, like the the baseline of what you need to know. So what do we really know about what happened on the night in May 2000? And then we pan down. So we introduce the 3D aspect really, really gentle. And then we take the readers back to that warm night in May in 2000. And then we establish the first actor, the father's house. Father is yellow. So now we have a visual anchor to navigate by. And again, it's really, really subtle movements with the camera compared to what we did on the landslide story. And here we have the girls. They are bathing, but they are not alone in Baneheia tonight. So that's basically the gist of how we do these sections throughout the story. And we need to help the user navigate. I think this is like the dev mode of the of the story. What you see here is basically the entire 3D model running in the browser via Babylon, and all of these orbs here, they are virtual camera positions, and the lines are like the interpolated camera pathing between them. And as you can see, this is a really much larger area than Gjerdrum. And we are going to go down into like street level all over the place. So we have to do it in such a manner that you don't get like seasick from watching it. So this is the starting camera angle that we introduced the story to. And in addition to that camera angle, we always start all other sequences like this. And the reason is quite simple, because this is like our approximation of how it looks like on a map, where up is north. So if you have been exposed to some sort of media coverage of this story for the past 22 years, and you maybe seen some sort of maps, this should be familiar. This is later in the story. Now we have been to the part of town that's up north, and now we're going to go down into the bathing place. Still, always after fading to black, we start at the same time. Really slow camera movements. And this is the other angles, similar to the one that we opened with, where we go through like the witness testimonies. So instead of moving the camera to all these places, we just like hang in the air and move the camera. If this was developed only for desktop, we didn't even have to pan the camera, but you know, this was designed for mobile, so that's why we need the panning. Also, in stark contrast to what we did with other visuals in the Gjerdrum story, everything you've seen so far has been virtual, just computer generated. So we needed a way to like cement our world, our digital model in the real world. So at the end of some sequences, we like end the final camera. We ended with a 20-year-old photo of the same place here at the road barrier. Later in the story, it's at the bathing place. It's a photo taken just days after, and that really helps to like validify our work, I'd say. Do you want to talk about the mobile?
Yeah, so I'll show you another part of the visualization, which is actually from what's been called the mobile evidence, which is a key part to why one of the persons was acquitted. And this has been also shown on various flat maps throughout the years. And it's all about how one of the suspects sent and received SMSs throughout the period of time when he was supposed to be raping and murdering the two girls. So we pan through various different angles here and show the points in time when these SMSs were sent and received, and we zoom in on the cell phone tower that they were sent and received from. And we also pan to an angle where we can clearly show how that's placed in relation to the crime scene, which will become visible soon. and render into the terrain the full coverage area, as was time and again checked and rechecked and checked and rechecked in the early 2000s. So you can see the way up there is where the crime scene was.
You can see it better once the box scrolls by.
Yeah,
now you can see
up here, and this is the theoretical area. So this was like throughout the trial. There were like doubts, could he really have been there? And then some technicians said, well, atmospheric complications, like reflected cell phone signals, etc. It could be possible, but nobody really thought it really was. So, and this became really one of the key pieces to the evidence when he was acquitted. In addition to like telling these stories, both the Gjerdrum and the Baneheia story with 3D, and I think to some extent succeeding in taking our readers there in a way that's better than the flat maps and like always the bird's eye view. Once you have the 3D model, there are obviously other things that you can do as well. And one of those things is VR, obviously. So you have the 3D model, you can export it to AR, you can embed it in various ways, but you can also expose it to VR headsets. So this is an example where I go into the model. This was never actually published. I think it's still a little bit early for that. But
just through the browser on the...
Yeah, so this is the Oculus Quest 2, Meta Quest 2, where I open the same story in the browser and enable VR, and there you are. And you can go down on the paths and really see the same locations yourself. And also, in the case of Gjerdrum, I expanded this somehow to you could, for one, actually land so that your feet were set on the ground level, which somehow helped with the immersion effect. Once you stand with the VR headset on and your feet are like your ground level corresponds to the 3D model's ground level, things seem strangely real, even if the colors and such are off.
I remember because we were toying around with. I was in Trondheim, you were in Asker, and we were just both in on a MetaQuest headset, and we were like, this was after we had worked for those 5 days and 5 nights, and having published the Gjerdrum story, and then we are both inside the world, just represented by a avatar flying, and even after working so intensely on everything concerning that landslide, it wasn't until I had the VR glasses on and I pressed the button to land on the ground and actually just stare outside the edge of the pit that I understood the scale of it.
Yeah.
It was unreal.
Yeah, and I had the same sensation, and I feel every time I've spoken about this for years now, and I don't think people really understand me or believe me when I say how real it felt and how groundbreaking that sort of visualization is. Like VR is clearly hyped. It has been hyped every time it's come around, but I think there's something there to be used in the future. We also enabled multiplayer, sort of a difficult word when it's such a dark story as Gjerdrum was, but in the VR Gjerdrum version, where we could go around together, like fly around together, and also speak to each other within that world. So the VR model of Gjerdrum became like our Google Meet. He was in Trondheim, I was in Oslo, and we can travel around, check out different camera angles, and discuss how can we present this. So I think there's something there for the future, but we aren't like quite there yet. That was Baneheia, a really interesting story to work on, and like an eye-opener to lots of technologies. Like 3D has been something that I've been interested in for years now, and will keep being interested in. But like early on in these stories, I was sort of a VR salesperson, I think, because I sold that concept to everyone I spoke to, and the same thing with AR. And we have to, like, as a media organization, capture 3D models of everything. We have to 3D scan everything, and all stories online, breaking news, what have you, should be 3D. And over the course of these years, I've gotten a little bit fed up with myself on that point. And also the pendulum swings like always, right? So go back a few years, VR was the thing, AR was the thing, and now it's not so much. Now it's all ChatGPT and generative AI. And I think we'll stay there for a while before everything like swings back to whatever we had before. Maybe NFTs once again. So all stories will be NFTs. I don't know. But I think that there's a lot of fun to be had if you're in like any sort of graphical presentation, be that stories, be that like digital twins or anything, within photogrammetry and the nerf space, like AI in grabbing 3D models of the real world, representing the real world true 3D models. And I'm really excited for those concepts, like nerfs in particular. If you haven't checked out nerfs, please really do. Those are really cool. Like photogrammetry, like the concept where you take photos of something and you like align points and make 3D models from them. Those are really terrible at reflections, whereas nerfs are perfect at capturing reflections as well. It's really, really cool. I think there's going to happen a lot there, but that like necessitates that we stop just making chat robots for a while and focus on back to the graphics in 3D. So please do that.
Yeah.
Yeah. One final note on this, though, and I mean, this is more of a note to self. I guess some of you work with or within storytelling. The thing that we got the most feedback on these stories were to be more accessible, not only because you like physically can't consume the stories in this way, but out of preference, really. So if we, like note to self, and if you ever publish such stories, I think it's a good idea to also publish an alternative, like have a pure text story for that guy in that chair who likes to read that, like only words, only like old typed out typewriter words. It's really not such a hassle to give them that, and I think it's a good thing for us to focus on as well. And this is surprisingly the end of this talk, 8 minutes early and all. It ends on sort of this Last of Us-ish kind of picture. As you might have noticed, the pictures at the beginning and at the end here are all Mid-Journey. So like I really hope that storytelling of tomorrow isn't just Mid-Journey everywhere, but it works really well for sort of a terrible presentation graphics like this.
Also, we have I added this QR code, so if you want to check out the landslide, Gjerdrum or Baneheia, there they are. Not paywalled.
And beyond that, I really want to get in touch with anyone who like are interested in these things. I'd be happy to help with anything, like pointers in directions or like whatever, because I think at least those of us in storytelling should work more together. We shouldn't be competing as much on the tools that we use and the processes, more like what we publish. So that's really something that I want to communicate to all of you guys and everyone who might watch this session later through video as well. Just reach out and let's do something together across companies, across borders, everything. And thanks for coming.
Thanks for coming.